Hello students, I am Subhashish. Let's dive back into the world of trigonometry and further solidify our understanding of fundamental identities and their applications. In the following examples, we will revisit some key identities and work through proofs and calculations. By doing so, we will enhance our ability to simplify expressions and solve equations using these powerful tools. Get ready to unravel the beauty of trigonometric relationships once again. Learning outcomes. At the end of this lesson, you will be able to reinforce understanding of fundamental trigonometric identities, improved problem solving skills in manipulating trigonometric expressions, enhanced ability to prove and simplify complex trigonometric equations. Keywords from this lesson are trigonometry, identities, equations, expressions, manipulation. In the previous session, we saw some examples of trigonometry identities. Today, in this session, we are going to see some more examples. Example: prove that under root 1 plus cos theta by 1 minus cos theta is equal to cosecant theta plus cot theta. Solution: consider under root 1 plus cos theta by 1 minus cos theta. Multiply numerator and denominator by the conjugate of 1 minus cos theta. That is, we get under root 1 plus cos theta by 1 minus cos theta into 1 plus cos theta by 1 plus cos theta. By using a square minus b square formula in the denominator, we get under root 1 plus cos theta whole square by 1 minus cos square theta. That is equal to under root 1 plus cos theta whole square by under root 1 minus cos square theta. Since sin square theta plus cos square theta is equal to 1, we can write as 1 plus cos theta by under root sin square theta. That is equal to 1 plus cos theta by sin theta. Now separate the terms, that is 1 plus sin theta plus cos theta by sin theta. Since 1 by sin theta is equal to cosecant theta, we can write it as cosecant theta plus cos theta by sin theta is equal to cot theta. So finally we get cosecant theta plus cot theta. Let us see another example. Prove that secant theta by sin theta minus sin theta by cos theta is equal to cot theta. Solution. Consider secant theta by sin theta minus sin theta by cos theta. Here secant theta we can write it as 1 by cos theta. That is equal to 1 by cos theta by sin theta minus sin theta by cos theta. That is equal to 1 by sin theta into cos theta minus sin theta by cos theta. By taking LCM, we get 1 minus sin square theta by sin theta into cos theta. We already know 1 minus sin square theta is equal to cos square theta. So, we get cos square theta by sin theta into cos theta. By cancelling the terms, we get cot theta, that is cos theta by sin theta. Let us see another example. Prove that sin A by 1 plus cos A plus sin A by 1 minus cos A is equal to 2 cosecant A. Solution. Consider sin A by 1 plus cos A plus sin A by 1 minus cos A. Taking LCM for the given terms, we get sin A into 1 minus cos A plus sin A into 1 plus cos A by 1 plus cos A into 1 minus cos A. Multiply the terms in numerator and use a square minus b square formula in denominator. We get sin A minus sin A into cos A plus sin A plus sin A into cos A by 1 minus cos square A. After simplifying, we get 2 sin A by 1 minus cos square A. We know that 1 minus cos square A is equal to sin square A. By that, we get 2 sin A by sin square A. By cancelling the terms, we get 2 into 1 by sin A. We know that 1 by sin A is equal to cosecant A. So, we get 2 cosecant A. Let us see another example. Prove that tan square A minus tan square B is equal to sin square A minus sin square B by cos square A into cos square B. Solution. Consider, we know tan is equal to sin by cos. Tan square A minus tan square B is equal to sin square A by cos square A minus sin square B by cos square B. Taking LCM for the given terms, we get sin square A into cos square B minus sin square B into cos square A by cos square A into cos square B. We already know 1 minus sin square A is equal to cos square A. Replace the values in the numerator. We get sin square A into 1 minus sin square B minus sin square B into 1 minus sin square A by cos square A into cos square B. Multiplying the terms, we get sin square A minus sin square A into sin square B minus sin square B plus sin square A into sin square B by cos square A into cos square B. By cancelling the terms, we get sin square A minus sin square B by cos square A into cos square B. Let us see one more example. Prove that cosecant theta minus sin theta into secant theta minus cos theta into tan theta plus cot theta is equal to 1. Solution. Consider cosecant theta minus sin theta into secant theta minus cos theta into tan theta plus cot theta. This we can write as 1 by sin theta minus sin theta into 1 by cos theta minus cos theta into sin theta by cos theta plus cos theta by sin theta. Taking LCM for all the three terms, we get 1 minus sin square theta by sin theta into 1 minus cos square theta by cos theta into sin square theta plus cos square theta by sin theta into cos theta. Here 1 minus sin square theta is equal to cos square theta, 1 minus cos square theta is equal to sin square theta. And sin square theta plus cos square theta is equal to 1. Substitute the values and multiply the terms. We get cos square theta into sin square theta into 1 by sin square theta into cos square theta. Cancelling the terms, we get 1. Points to remember. Trigonometric identities are fundamental rules in trigonometry that relate the ratios of the sides of a right triangle. These identities can be transformed into alternative equal forms, allowing for the simplification of trigonometric expressions and equations. Trigonometric identities are sin square theta plus cos square theta is equal to 1. 1 plus tan square theta is equal to secant square theta. 1 plus cot square theta is equal to cosecant square theta. Thanks for watching.